Okay, guys. Actually, Greg asked a great question. So the rest of the unit, how is that going to look? So today is obviously the 6th. So we're going to finish off what we didn't finish on Friday. We're going to finish it off. And we have another section to do as well, but it's pretty short. Then we have 2 more sections to cover. They're on something called rational functions, like graphing algebraic expressions that fraction them, like 1 over x or 1 over x plus 2, stuff like that. We're going to do that on Wednesday and Friday. Friday is our last day of new material for the whole school year. I'm not doing any more material after May 10th. Because then when we come back on the 13th after the weekend, we'll review for the test. Our test will be Wednesday, May 15th. Then we have 4 full days of final exam review, the 17th, the 20th, the 22nd, and the 24th. The final exam is on the 28th. There's a little bit of a discrepancy what's published here and what's published in the newsletter. Because the newsletter says the math final is in the afternoon, but this says the morning. So I need to get some clarity on that. I'll let you guys know hopefully by Wednesday, because I'm meeting with the Algebra 2 teachers tomorrow. Cooper, good, yeah.
Be taking it in here or
Great question. I don't know about that either. That's another great question. I don't know. So I'll get clarity on that hopefully by tomorrow and give you guys straight answers about it by Wednesday. But yeah, but I don't want to do any more new, because really the final exam is 22 days from today or 3 weeks from tomorrow. So really this is the last week of new material, and then we just do one more test, final exam review, take the final, done the school year.
Is the final, is it just second step?
Yeah, I mean, of course, yes, you do need to know like skills, but anything that's specific to the first semester you didn't reinforce, no, of course not. I don't know what that is off the top of my head. I couldn't tell you. But anyway, let's go over this work right now. So for 8-134, these problems may have been a little challenging, but here's how you can approach them using the skills that I taught you guys last week. So we remember we talked about that Polodoku, that long division type thing. So one thing you could do is take a look at A, right? And ask yourself, well, what is a 0 of this function, right? What value of x will make this 0? What do you guys think? Should be pretty obvious, hopefully. 1, perfect. So it means that x minus 1 is a factor. That's what it implies, right? But yeah, so if you look at the expression x cubed minus 1, what value of x would make that 0? Like if you just look at it, hopefully we could tell that x would be 1, right? And so that means that x minus 1 is a factor. So then I'm going to do the division using x minus 1. And use this little technique here, like, you know, the Polodoku thing, right? So it's x cubed is what we're dividing into. So we should make 3 columns. And I'll put x and -1 here. And I'll put x cubed and -1 here. And then what I'm going to do is just go through the motion, right? Just do it. That's x squared. That's -x squared. Now, this expression can be written like this: x cubed plus 0x squared plus 0x minus 1, right? So there's no 0x, there's no x squared. So if you have -x squared, I need a positive x squared to balance it out. Therefore, this has to be x. That's -x. I need a positive x to keep that balance out because there's no x in the original expression. And of course, this has to be 1. So x cubed minus 1 can be thought of as the same thing as x minus 1 times parentheses x squared plus x plus 1. Now, this right here is a quadratic expression. You should use quad form, right? Because it's not factorable. So if you wanted to solve it, but actually we don't need to do that because it didn't ask us to do this. So I'll just stop there. It didn't ask us to do that. So at this point, we're good because it just said to factor it. So that's how you can go about that process. Now, on the board, I know there's lots of you can't see it, but I'll put this up a little bit. Actually, I'll write on the board. So I'll write on my screen. So there's also a formula that goes with cubic functions. Looks like this, guys. Guys, quiet, please. Elliot, can you please be quiet? Thank you. Thanks, appreciate it. Yeah. So this is a formula we're going to talk about later today. It's called difference of cubes. So you can see how it pretty much aligns with x cubed minus 1, like a cubed and x cubed are in the same position, -1 and -b cubed are in the same position. So you see that a is x and b is 1. A is x and b is 1. Oh, bless you. So if you replace a with x and b with 1, you wind up getting what we got in the first place doing the Polodoku thing. So there's also a formulaic way of approaching this as well. And you can do likewise with b, c, and d. We'll actually talk about this near the end of the notes today. So that's how you go about a problem like that. I don't have to do all 3 in the interest of time, but if I show you the answer for b, c, d for 134, There you go. Those are the answers. Like, for example, for D is x cubed minus 125. And remember the form I just showed you was a minus b, a squared plus ab plus b squared. So think about it. A cubed minus b cubed equals all that junk. So x cubed and a cubed are in the same position. B cubed and 125 are in the same position. So you could say a is x and b is 5 and just plug it in, and you would get that as well. Actually, it's plus, my bad. If it's plus, you actually didn't have to reverse this. I also have on the board as well. Sorry about that. And that's because 5, negative 5, sorry, would make this 0. So then x plus 5 is a factor. Because x equals negative 5 would make that 0. So those are ways you could approach that. Moving right along, for 138, they tell you that you have this polynomial here, and they say x minus 3 is a factor. It's great. Then a person tries some other factors, but didn't have any luck. So because they all had a remainder. So if it's crossing at 3, but it's bouncing, right? So what does that mean when it bounces? It should be squared, exactly. So x minus 3 can be factored out again. So you got to do this again with that polynomial. So I'll put x and negative 3. Let me get rid of that arrow there. But I got to do it again. And I'm going to put x cubed and positive 3. And just go through the motions again one more time. So that will be x squared, negative 3x squared, 2x squared, 2x, negative 6x, negative x, negative 1. We're all good. So you get x squared plus 2x minus 1. And if you were to actually do quad form, and I did this in the last class, so just trust me, this is how it works. I think it was 2 plus minus root 2. I think that was the answer. Sorry, negative 2 plus minus root 2. I think that was it. No, am I right? Hold on. It's going to be 2 plus or minus b squared, which is going to be... Sorry, my bad. It's 1 plus minus root 2. My apologies.
The graph allows us to get an exponent, right?
Yeah, exactly. Because we see a known one at 3. But then after I do the division, because realizing it bounces, I have to divide by x minus 3 twice, right? I do it once.
Because of the bounce means it's squared.
Exactly, right. 100%. So this is where we're being more analytical. Now we're starting to do the graphical algebraic connection, right? This is good. This is a good thing. Because we see that, oh yeah, algebraically, it means we've got to have x minus 3 squared. Graphically, we see it. But what does that mean algebraically? X minus 3 squared is a factor. So you divide x minus 3 once, do it again with the remaining polynomial. Once you have broken down to a quadratic, do quad form, you get 1 plus minus root 2. Just trust me, I did this right. So anyway, 1 minus root 2 is sorry, it's negative 2. Oh goodness. My bad. I'm a little off here today.
So the reason why it didn't work is because it was an x minus 3 squared.
Exactly right. Yeah, because the person tried other factors which didn't make sense because they don't see it crossing the x-axis at those places, right? Even though those are factors of the constant, we talked about how the factors of the constant can be possible zeros, but they just don't work here. But then when I do quad form for the quadratic afterwards, negative 1 plus minus root 2. Negative 1 plus root 2 is 0.414. That looks pretty good. Negative 1 minus root 2 is like negative 2.4. That looks pretty good. So we're okay. All's good. So that's how the graph helps, and we completed the problem. Then a couple more problems I want to talk about. Well, for 148, if you plug 2 in, you get 0. So this means 2 comma 0 is on the graph. Okay. 2 comma 0 is on the graph. Well, that means that x minus 2 is a factor. So what happens when you plug a number in, whatever the output is can be the remainder if you do x minus this number. So the remainder theorem states if you have if p of c equals a, then p of x divided by x minus c will equal some junk with a remainder of a. So the output is going to be a remainder, but because our output was 0, there is no remainder. That means that 2 is an x-intercept, or x minus 2 is a factor. So now that's what's part B telling you, is that yeah, find one factor, it's x minus 2, and then actually do the division for part C, and then state all the solutions. If I actually show you the division, this is the answer for 148. So P of 2 equals 0, x minus 2 is a factor. If you do division, you get that. We know how to do the Paul-Doku thing. We don't have to do it again. And if you do quad form with this remaining quadratic, you get 2 plus minus root 5. So that's what they want you to do for that one. And then lastly, for 154, here's the answer. Actually, this should be 2 plus or minus. Sorry, -3 plus or minus 2i. Let me look at the question. What's the question asking us? The question is asking us to, find x-intercept, which is 2. That's easy. So x minus 2 is a factor. Then break it down. Do the Paul-Doku or long division, whatever you want to do to divide out the polynomial. Get what's left over. Do quad form. If you do quad form with what's left over, you should get -3 plus or minus 2i. So, and then they want you to write as a product of factors, I guess. No, they didn't ask that. Just to turn the real complex zeros. So there you go. So I'm not going to assign all the other problems here because for the most part, I think you guys get the idea of how to do the homework. But we still need to finish off the notes. So let's finish off the notes. Shouldn't be too long. And then we have no set of notes to do, which is also pretty short. And then we're done. And if you guys want to go hang out outside, we can, because it's a beautiful day. So beautiful day. Yeah, you guys can hang out outside. All right. So let's get back to notes, guys. Please. Thank you.
This is number 6.
Yep. Okay. So notice what I did for number 6. I'm doing factor by grouping, guys. What can you take out of the first group? X squared, right? More than just x squared. So it's x plus 1. What can you take out of the second group? -7. You still get x plus 1. So the beauty about this is that x squared, let me get a highlighter here, because some people get a little confused with factor by grouping. So you have x squared, and you have -7. Totally 100%. But then you have x plus 1 and x plus 1. So the x plus 1 actually gets pulled out. And what's left behind? X squared minus 7. If you FOIL it, you get back to the original expression. So where are the roots? The roots are -1 or plus or minus root 7. We get 1, 2, 3. Okay. Oh, which one? Sorry? You don't have the notes? You should have them, no? Oh, if you can't find, just let me know. I might have an extra copy. Okay, so -1 is the x-intercept. Now, root 7 is in between what two numbers, guys? Root 7 is in between what two numbers? Well, two whole numbers. What would you guys say? Oh, I did factor by grouping.
So I group that x, so I group the first and last two, pull x squared, pull out -7.
Oh, and then just it's -7.
And x plus 1's being multiplied both x squared and x, since I pull out the x plus 1 and left hand x squared minus 7, right?
No worries. Okay, you guys quiet, please. So we cross at the root 7 is in between what two numbers? 2 and 3. Thank you. And -2 and -3. And what's the y-intercept here? Right. And the end behavior, remember, when the degree is even, both arrows go in the same direction. Like they're even. They see eye to eye. They're equal. Think of it that way. Even degree, they both go up or both go down. They both go up if the coefficient is positive, but both go down if it's negative. Hopefully that's intuitive. If you have an odd degree, the arrows are at odds with each other, going opposite directions. That makes sense. So if you have an odd degree here, now if it's positive, you're going to want to end up eventually. If it's negative in front of x cubed, then you want to end up down eventually. But in this case, one up. So the graph looks like this. How high it goes or low it dips, I don't know. That's calculus. We're not there yet. That'll be a year and a half from now, or even a couple of years probably. You'll do that stuff. But yeah, that's what happens. So that's number 6. So again, we're doing some algebra, did some factoring, found the x-intercepts by setting the equation equal to 0. Right? Just let that equal 0. And after you factor it, between 2 and 3, because root 4 is 2 and root 9 is 3. And root 7 would be between root 4 and root 9. So just using some intuition, right? Let's look at 7 next. For number 7, okay, find all roots for this function here. Now, what would be an x-intercept here? What would make this 0? Just using some intuition. What value of x was that? -2, thank you. If that's a root, then x plus 2 is a factor, right? So I'm going to do the Paul-Doku thing. X and 2, x cubed, and 8. Now, what do you multiply x with x cubed? X cubed, x squared, right? So that's 2x squared. Now, there's no x squared in here, right? Yeah, Greg, go ahead. Yes. Yes, I'm not going to do that just yet, but yes, on the next set of notes, we'll talk about that. Well, you don't have to, because you can do this right now, what I'm doing. You don't have to, because this works. But yes, let me talk to the other Algebra 2 teachers to see if we'll give that to you guys. I don't know yet. So, but there's no x squared term, so I'm going to put -2x squared. So this has to be -2, making that -2x, sorry. I'll back up. Okay. So do you see how I got 2x squared? Okay. So because the original expression has no x squared, the 2x squared needs to be canceled out. How do I cancel the 2x squared? By putting a -2x squared. Because remember, anything inside the box is combining like terms. Anything outside we multiply, but anything inside we're just adding or combining like terms or subtracting like terms. So then this has to be a -2x, making this a -4x, making that a +4x. Okay, let me back up. Let's back up. Okay. Yes. Yeah, so I put -2x. So this is -2x squared. We're okay? Okay. No worries. Ask questions. It's all new stuff. -4x, 4x, 4. Okay. So you get x squared minus 2x plus 4 equals 0. So you have to use quad form for this one. That'd be 2 plus or minus b squared minus 4ac all over 2a. So x will equal 2 plus or minus 2i root 3 over 2, or 1 plus or minus I root 3. Here's the problem. That's imaginary. Will that be an x-intercept? No. So it should only cross the x-axis once. At what value does it cross the x-axis? Good. Now you're starting to see the algebraic graphical connection. That's awesome. That's very good. Because then if I look at this graphically, because that's what we're asking us to do here, I know we're going to cross at -2 because we said that we established that already, right? We already established that. So now I'm going to cross at -2. Come on. The y-intercept is 8. 1, 2, 3, 4, 5, 6, 7, 8. The end behavior is going to be like this, right? Up, down, and up, right? We have to be pointing down to the left, pointing up to the right. So it's kind of like that. Because we can't cross anymore because you don't have any more x-intercepts. You have 2 imaginary and 1 real. And following the end behavior. So not a terribly accurate graph, but at least it's a pretty good graph because you know the end behavior, you know about x-intercepts, you know if you have imaginary zeros, they can't cross. So why do we care about imaginary zeros? We care about them so that we make sure our graphs are accurate, because even though it's degree 3, we're not going to have 3 x-intercepts, only 1, because the other 2 are imaginary. No, but go ahead.
On graphic,
Mhm.
how do you know whether it's like, I know when it's x squared, it goes like that, but how do you know when it like has a big?
You don't, because you'll get them when you get to calculus. You won't.
If you have like it's x axis, would that still be correct? Or would it, like,
Well, this has to touch the x-axis at -2.
I mean, like
This one.
on like the positive quadrant. or
Oh yeah,
thing.
yeah. No, it can't be touching the x-axis at all. Is that your question? Okay. Well, maybe the next page might clear things up. Let's move on to the next page. Because the next page kind of runs through a bunch of hypotheticals. Like if you have a quadratic function, right? What can happen here? This could happen, right? This could happen. Or this could happen. We already had this discussion in the last unit. So this is 2 real. This is 1 real. Remember we have a bounce here, right? And that's 2 imaginary. We've seen that already now with a quad form. And that's a bounce. That's a terrible handwriting. Let me write that more nicely. Sorry about that.
With no x-intercepts means you imagine.
100% correct. Right.
Will we have to graph that?
No, I just want you to know how the graph looks, just hypothetically speaking. I mean, it could be pointing down, but not touching the x-axis. Now for cubic, where degree is 3, it could look like this. Or it could look like this. Or it could look like this. I think that's all the possibilities. So you could have 3 real. You have 2 real, where 1 bounces. Or you have 1 real and 2 imaginary. So that's a possibility as well. Because we just did that problem previously, right? We had 2 imaginaries, but 1 real. Does that kind of answer your question, Alba, or I'm not sure if you
Yeah.
clear things up a little bit? Yeah.
Yeah.
But we could bounce, right? That's possible. So that's a double root. Like would that be like x minus 2 squared times x plus 4, whatever, I don't know, something like that. So those are the possibilities for degree 3. Now degree 4 gets a little funky, so bear with me on this one here. There's quite a bit of space here for this one. Degree 4, quartic. You could have this. Quartic, I know. So you have 4 real. You could also have this. We have 3 real. Or you have this. Oh, I missed. You have 2 real. So here you have a bounce. Or here you have two bounces. Okay. Or they can never touch. So it'd be 4 imaginary. Or it could bounce and never touch again. So it could be 1 real. And the imaginary is always going to come in pairs, by the way, guys. Or it could look like this. Where it's 2 real. And I think it exhausts all the possibilities. The imaginary is always come in pairs because you assume that your polynomial has real coefficients. So you get 4 imaginary, 2 imaginary. There's a lot of different possibilities here. That's kind of crazy. So, I'm not going to venture into degree 5 because it's a little much. Okay.
We're only.
So
This
let's
is
look.
like the kind of question we get on that.
I haven't just we don't know what's going to be on test yet. I'll let you guys know because we're going to talk about it tomorrow. So I don't know yet. I mean, maybe there could be some multiple choice question, perhaps, like,
Oh, that's fine.
or maybe we could just say explain or show me a situation that could have that, or can this happen? So it could be stuff like I don't know. I don't know yet. I can get really creative with these kind of questions. So, all right. This last set of notes in your packet. I know you guys will get a new packet on Wednesday. So let's skip this problem here because we already did this. We already did this and this, and I don't care about 5th degree. That's just too much. But I mean, degree 5 could have 5 real, could have some imaginaries. The one thing you want to keep in mind, the key takeaway, imaginary roots come in pairs. So if you have A plus BI, you have A minus BI. Just remember that. Imaginary roots come in pairs. I think that's a key takeaway. And then whatever's left over would be real, right? Like, for example, for degree 5, you could have a pair of imaginary roots and you have 3 real. Or you have 2 pairs of imaginary roots and 1 real. That could happen. Or you can do like a double root. When you want to get really creative, you can do a quadruple roots. You can do like triple roots. But I don't want to list all possibilities because I think it's going to drive you guys a little nuts. I think you guys get the idea what we did on the last set of notes. So let's just skip this problem, move on to the next one. Okay, this I kind of care about because this we will most likely have on our test. And I do care about these kind of problems, how to solve these. And then I'm going to talk about factoring one more time. And then we'll be done with the notes. So we still got a little more to go, guys. But the plan is next 10 minutes, we can just let out early and just enjoy the outdoors. So this problem here, if you actually want to divide this out, so here's what you want to do. You want the final answer to be written that's what we're trying to achieve. We want to write this more compactly. How do we do that? I'll show you how. Guys, quiet, please. 3 plus 2i, yikes, over. There's something called a conjugate. The conjugate is a minus bi. It's basically the opposite of a plus bi. You just change the sign of the middle. So what you're going to do to this fraction here is multiply top and bottom by the conjugate of the denominator. The denominator is -4 plus 7i. The conjugate is -4 minus 7i. So it's always the opposite sign for the imaginary part. Then what you have to do is FOIL twice. and clean it up. FOIL twice and clean it up. So let's look at the top here. 3 and -4 is -12. 3 and -7i is -21i. 2i and -4 is -8i. And 2i -7i is -14i squared. Does that make sense? What I just did? Do you guys follow? I just foiled, right?
So -12, -8i, -27i, and then -14i squared.
A lot of negatives, yikes. Oh my goodness. It's pretty intense. If I foil the bottom, -4, -4 is 16. Then you get 28i and -28i. And -49i squared. Now we gotta clean it up. So this is called complex number division. We've done addition, subtraction, multiplication, not done division yet. But
14i squared, we don't.
yeah, so here's what we're gonna do. Those cancel, right? You guys see how those cancel? And then this becomes what? Positive 49. This becomes what? Positive 14. So my final answer is going to be 2 minus 29i over 65. Or we write like this, 2 over 65 minus 29
Wow.
because that guarantees that we have an a plus bi form.
Now I can easily identify what A is, which is 2 over 65, what B is, -29 over 65. That's why I do that.
So it's a way to express it more compactly. Now the graphing calculator, TI4 calculator does this for you. If you hit second decimal point, there's actually an I feature, but unfortunately we won't let you use it because we know this. But if you're taking, say, the SAT or ACT, like if you're taking it next month, for example, they do sometimes complex number stuff, and they know this, but they still allow the calculator, so you could just actually punch it in pretty easily. Just make sure you put it in parentheses, the top, bottom, and I second decimal point, but I'm not gonna let you guys use it on our test. All right, let's talk about these problems here. I'm gonna move this 2 over to the side. And then square both sides. Does that make sense what I just did? You guys follow?
So what I do is I move that 2 over from left to right. Why did I do that? It's easy to isolate the radical. You can isolate the radical. It's easy to do that first, then square both sides afterwards. So I move the 2 over, square both sides. Remember, when you square a radical, they knock each other out because of inverse operations with each other. And the right side have to FOIL, right? You can't just square x and a 2 separate. Please don't do that. That's the one thing that gets my nerves. It means you're not respecting order of operations, right? To respect order of operations, you have to FOIL it with yourself. You get this. The way thing I do after that.
Move X over.
Yeah, then it becomes a quad x function, which I know you guys can solve, right? And it's actually factorable, which is really nice. And you get 2 answers, which is awesome. But here's the problem. One of these answers may not work. Sometimes both of them may not work. So you got to check the answers. You have to actually verify if they work, because they call them extraneous solutions. It's just the nature of radicals. This happens sometimes because graphically it has to be confirmed. If you graph each side and look for the points of intersection, in fact, actually there's only one point of intersection, not 2. So if I plug 1 in, does 1 work? No, unfortunately not. No. Does 4 work? Yeah, because I changed my tone. So of course 4 works. If you plug it in, you get 2 plus 2, which equals 4. Bingo, works. So it's good. So you do have to check the answers. Otherwise, we could be misleading with our solutions. Does that make sense how I approach that one? Now, B is a little more tricky. Why do I say B is a little more tricky than A? Yeah, rocking both sides. So what I'll do is we'll just square both sides right from the beginning. So the right side's easy. That's just x plus 6, easy peasy. The left side, I have to FOIL. So I want to actually show them foiling. So you get x plus 2 root x plus 2 root x plus 4 equals x plus 6. Clean it up a tad. Hey, what do you got on each side? Sorry, what can you cancel on each side? Sorry. Long day. X's go away, right? So 4 root x equals 2. Root x equals 2/4.
It's about 4, root x plus 4.
If I move the 4 over also. So x will be 1/4, which should work itself out. If you plug it back in, you get 2.5 on the left side. You get root 25/4 on the right side, which is also 5/2 with 2.5. So it works. So this, I think, is review of old stuff. I think we've done this before. I don't remember. CPM's kind of a funky curriculum. I still kind of they bounce around a lot. So I think we've done this, but hope this makes sense because these are equations we want to be comfortable solving. Okay. All right, last page. I know you guys have been very patient. Thank you for a beautiful spring afternoon. Difference of two squares looks like that. Now, for the cubic functions, the a cube plus b cube, a cube minus b cube, I have it on the board. And Greg had asked, like, will I give this to you guys on a test? I don't know yet. I'm meeting with the other Algebra 2 teachers tomorrow. I'll have more clarity on that. But you could just also derive them by just what we did with the Polidoku thing, right? Like, for example, for number 1, I know x equals -3 is a 0, right? I know this. So guess what? X plus 3 is a factor. And notice I see that over here, right? Does that make sense how I made that connection, right? A cube plus b cube, x cube. So then guess what? I'm just going to do x squared minus 3x plus 9, done. So sometimes when you have that formula, it's really nice because you just go straight to the answer. It is really nice. It's a luxury to have that. So let me find out if we'll provide that. But -3 is a root. So great. Just do the rest. Now 2 is a little more challenging. I'm going to rewrite like this first. And I'm going to get a little highlighter here and compare it to the proper formula. So the 125 is kind of like here, right? And the 64x cubed is like this over here, right? So what's a going to equal then? If a cubed is 125, what's a going to be? 5. If b cubed is 64x cubed, what's b going to be? What's this cube root of 64? 4x, right? Because what happens when I do 4x 3 times? 4x, 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 64x cubed. So now I just plug and chug into that formula. 5 minus 4x. A squared is 25. A times b is going to be 20x. And b squared, of course, is 16x squared. There you go. Just to line it up more nicely with the formula. That's why. Just so it lines better. That's all. You don't have to. I just felt like it. So it lines better. Okay. Okay, we'll do this really quickly. So this is going to be like a quadratic. X cube, negative 27, and plus 1. It's kind of like if you did the diamond, right? Negative 27, negative 26. Negative 27 and 1. So, but x6 breaks apart as x cubed. And then you can break it down even further by using the formulas up above in this fashion here. Yep. So there you go. We're okay. Then here, factor by grouping, factor on x4, and factor on negative 16. And the two parentheses should equal each other. So then x squared plus 2 can be pulled out. And you're stuck with this, right? Then you go even further. I'm going to change colors. Yeah. So it's more factoring practice. That's all. Of course. Because law notes, thank you. I feel like we closed a big loop. So now we could move forward to the last two sections, one on Wednesday, one on Friday. Done with the new stuff, be in review mode. And all the review, the tests that we're taking next week, it's gonna help you for the final two, right? I mean, obviously. So yeah. So anyway, that's what we got there. Okay, I'll stop the recording, but keep this up if you guys are still simmering over it.